Hey guys, it's Vince. Today in this video we are covering volume number 25 in the CNC Controllers Built Incorrectly series. For those of you just tuning in, and I've said this in my previous videos, I highly recommend you guys go back and check out the earlier volumes in this series so that you can see the patterns that these content creators follow. When I say patterns, I mean how they mimic one another. This is what we see all over the internet with misinformation. So that being said, to make that even easier, I've created a playlist. All you have to do is go into my channel, go under the search bar and type in CNC Controllers Built Incorrectly, and you'll get up to this latest volume in the series in sequence. So if you're serious about building your CNC controller, I highly recommend you check this series out. Again, it's not based on simple entertainment, it's based on education. In fact, guys, do your own research. Let's jump right in. Okay guys, in the previous video I explained that I would be showing you guys as my resume continues to expand because, again, using the internet for this purpose I think is amazing to document in real time your background, and I recommend you all do the same with whatever genre you're in and any skill set you have. Once again, I'm performing a retrofit on a Gerber Dimension 200 CNC router for the client of Emil Mashak. That's the client's name. So looking at Mr. Mashak's background, he is Chief Technology Officer, Information Technology at NASA Dryden. He was there for 17 years and 3 months. And just so everyone is aware, that's Neil A. Armstrong Flight Research Center. Now considering, and I know many of you out there have been told this yourselves by your parents. I was always told, and I said this in the previous video, that my father always said to me, Vin, whoever you hang around with is who you're going to be judged by. Considering the minds that were surrounding this gentleman, and then to watch my YouTube channel and then contact me, I believe that says a lot. And I've been honored to work with him. I thanked him for his service. And once again, I cannot emphasize, guys, be careful with the information you watch from content creators. Research everything, and remember, entertainment should not be confused for education. Okay, we can already see that the content creator, like many before him in the 24 volumes previous, has selected a USB breakout board. Now, many of these content creators select these breakout boards because of the cost. They think they're doing themselves a favor by having the accessibility of USB instead of using a parallel port, because that's what many of them are trying to get away from. Unfortunately, they do no actual research on how unstable universal serial bus connections are for CNC applications due to their susceptibility to voltage spikes and grounding along with EMI. Once again, I'll post the email that was in discussion with Balzas at CNC Drive, the lead manufacturer of the UC100, and you can see that for yourself. I'm also going to answer a question that came up, and this is a good question, and that was, does it matter what USB connection the board uses to dictate how stable it is? No, it does not. USB does have different types of connectors. I'll put them on the screen here. If your board has any of these connectors to send and receive signals from your PC to delegate to the drives, you can rest assured it's universal serial bus and should not be used in best practice.
All right, so going over the instructions that came with the breakout board here, it actually wants a 12 to 24 volt power supply input for all the inputs and outputs that the board runs.
So we see that the content creator, when shopping overseas, and this is where he purchased his controller access kit, and that came bundled, of course, with the 3 power supplies. Now, guys, I cannot emphasize enough how bad of an idea it is to have multiple drive power supplies in a small electronics enclosure. First and foremost, it's not required. And especially when we're dealing with sensitive electronics, all you're doing is, when you're pulling more power, you're also releasing more electromagnetic interference, also known as EMI. Doesn't make sense to do that. Best practice is to find out how many amps each individual drive will require to supply motor that he actually selected, and then you would incorporate a power supply. Pending, of course, it has the amount of amps required, you would select a single power supply to power all of the drives. Number one, it would use less real estate within his electronics enclosure, and of course, it's going to mitigate most of the EMI. Now, the thing to keep in mind, and I'm going to put this on screen, is Gecko puts together a real easy section 6. It's called a power supply. You can see here on their site, it states that the easiest factor in choosing a power supply is its current rating, which is based on your motor's ratings. A motor control will always draw less than 2/3 of the motor's rated current when it's in parallel or half winding connected, and 1/3 of the motor's rated current when it's in series or full winding connected. That is to say, and this is an example, a 6 amp per phase motor will require a 4 amp power supply when wired in parallel and only a 2 amp power supply when wired in series. Now, most of you will wire your motors in series. If multiple motors and drives are used, add the current requirements of each to arrive at the total power supply current rating. Now, had he done the research, of course, he would have seen this. However, you guys now are one step further in your journey because now you hopefully understand this, and it will definitely save you money. I cannot tell you how many guys spend more money on a power supply than they actually need. Now, one thing you will pay attention to, or would want to pay attention to, would be how many terminals that power supply has. Most of the switching power supplies on the market only have usually about 3 outputs for power distribution. That's where I designed my 48 volt 600 watt unit at 12.5 amps with 10 power output terminals so that when you hook up multiple accessories for CNC applications, you will have all of the terminals there and you don't have to install a terminal splitter for power distribution. Saves you an inordinate amount of time and of course saves you money. It also is one of the only switching power supplies I'm aware of that has a built-in EMI filter for CNC use.
Alright, so here we've got a bunch of connections that are just going to be going to 5 volt, and what they are is it's going to be the positive side for pulse and direction, and the positive and the negative for the axis enable.
Right, guys, he's going to begin wiring the drives, and like many of these content creators, what they like to do, of course, is discuss all the terminology that they believe they understand. And it's interesting because what defines that they understand the terminology that they're working with is how they wire the drives. Let's see where this goes.
So to connect all the 5 volt stuff up, I'm going to use this wire here. It's 18 gauge, it's well insulated, and it's stranded wire, copper wire in there. So it's going to actually do a really good job carrying that 5 volt signal across. And
it's truly apparent as this content creator is discussing the cable that's going to be carrying his 5 volt signals. He truly doesn't understand what really matters in the stability of the system, in that he would have explained that's all good and fine that it's stranded cable, it's all good and fine it's copper core, it's all good and fine that the insulation is good, but without the proper double shielding, your signals are at risk for EMI penetration, in which case then they become corrupt, in which case then the robot becomes essentially a paperweight. This is the detail these content creators do not understand. And you guys, the more you pay attention to these videos, you become more adept at spotting the knot. That's the purpose. It's not about BSing you and making it fill time with more and more content, once again, for entertainment. It should be that they're not just regurgitating what they think they get to try to imply to their audience, hey, I know what I'm doing. They have no idea what they're doing.
on this side, I couldn't see the labels correctly on that side, but I moved them over. They're actually supposed to be the 5 volt positive for pulse and direction. So I moved the white and greens over on all 3, and then for the negative connections I ran these 18 gauge wires around into the pulse and direction pins for X, Y, and A.
I'm sure many of you, like me, always wonder how these content creators can assemble a controller in roughly the same time frame. If you go back in my volumes, you will find that in this video series, the average time frame for a video is about 20 minutes. It's amazing they can all wire controllers within 20 to 30 minutes, yet never discuss the proper use of double shielded cable, never discuss a ground bus, never discuss use of proper ferrites with proper frequency to make sure that if we're not going to use double shielded cable, we have passive filtering to make sure our signals are protected. They never discuss any of this. They go from A to B in connections and the system is done. If you go on CNC Zone, if you go on all these forums, and I've said this before, these are the causes that we see so many unstable systems. That and the fact that many guys do not understand using the proper breakout board in terms of what connection it actually utilizes. Is it using USB? Is it using Ethernet? Is it using EtherCAT? Again, if you don't understand the details of what you're working with, you will essentially sabotage yourself, and these guys, if you listen to them, can cost you thousands. So once again, we see the content creator do like so many others do. They accelerate the video and he's showing you his soldering process. And once again, like we've seen in previous videos with these content creators, it is completely wrong. He is only using solder. He is not using solder and flux. And once again, without flux being incorporated into the process, you have a compromised connection. And if we look at these connections, you can see exactly what happens when content creators mainly, or any end user for that matter, decide to solder without using flux. They believe, for some reason, that flux is not required. It is simply an add-on. I've heard that many times before, and I don't know where that came from, because you will not find a plumber, and I go back to that analogy all the time, sweating pipes. Pipes are critical. They know that they're critical, and they know that their job is super important because you don't want to leak. You must sweat the pipe with flux and solder to do it correctly. That formulates a proper weld. It works the exact same way with electrical or / electronics. You will not get a perfect weld if you do not use flux to allow it to properly clean the terminal as well as formulate capillary action with the solder for proper wetting and penetration so that that weld is the strength it's meant to be. I cannot emphasize this enough, guys. Watching these guys work is really painful to anyone who's within the electronics industry and understand what I'm talking about. That is why I feel I'm drawing the eyes on these videos now that need to see this, because more and more guys are witnessing this and asking the same question like, he can't be wrong, you can do the research and figure it out. The scene you just witnessed is probably one of the most powerful scenes you will ever witness in any of these content creator videos, in that there's a lot to be learned. You saw how fast, because of course he accelerated the video, he attached a crimp connector on both of those leads. Now on the other end, he soldered. Now mentally, he didn't go, why am I soldering one end and why would I use crimp connectors on the other when they felt it necessary to use solder on the other end? They don't think like that, guys. What they're doing is trying to get the job done as fast as possible. You saw the crimp connector tool he was using. You also witnessed him not even check the crimp connectors with a multimeter to make sure conductivity and everything is where it should be as far as conduction. Now, thinking about that extra step I just pointed out, what do you think I just saved you? If you're going to use crimp connectors, which I never recommend, I always recommend solder joints, but what do you think in time that would save you and money if you found a crimp connector that required replacement? That's the difference between experience and somebody just wanting to film a video for entertainment.
The sub connector parallel port on your computer. But after Windows XP, no one had the old printer port, everything had to be a USB connection. And that is why I went with this USB controller. It was inexpensive. It cost me with the hand wheel, the software, and everything less than $100.
So we're at the point in the content creator's video where he's happy to explain how much he paid to convert from parallel port using Windows XP to now being able to use USB with integration so that he can use the latest Windows operating systems and of course whatever PC he likes. And he's bragging about what he paid for his controller. Now this is interesting, guys. We're seeing the breakout board, we're hearing about the pendant, we're hearing about the motion control software, and all of that came bundled for about $100. Where's the logic there? I want you guys to think about that. You honestly, with robotics, get what you pay for. There's a reason you're paying what you're paying. And when you think about paying $100 for a breakout board, motion control software, and a pendant, that is absolutely ridiculous, considering your motion control software, Mach 3 alone, and I'm telling you this as a vendor, is $175 from Artsoft. So when you think about that, you have to wonder what the logic is from one person to say this makes logical sense in that everything else is free. So in his mind, he's thinking, I got a great deal, no corners were cut. Most people would say, hey, I'm going to research this a little more. Something here sounds too good to be true. Does it? I want you to think about that. And mind you, think about this. Looking carefully at what we see inside his electronics enclosure, once again, we see uninsulated connections on those GX16 plugs. And of course, we already know he doesn't use proper flux when he's soldering. So again, that process is completely a fail. Think about what you're listening to, and I'm really hoping his audience can decipher it. Because what we're seeing now with mass misinformation being given is information given around the content creator's best interest. They want to show you, hey, I only paid $100, you can too. I'll put the link in my video description. What they're not saying is, maybe I made a mistake. They're not telling you that. They wait for you to figure that out. Let's hope we can figure it out in this video. All right, guys, you can see here I took a snapshot from that one portion of the video where he's showing his connectors. And I'm using Topaz's Photo AI software because as a content creator myself, I like to use this software to enhance images, especially for clarity or where there's lighting issues like we see here. And I want to show you forensically what these connectors look like when they're finished. Once again, the beauty of using AI software correctly and for the right reasons, we can learn a lot. So let's click on this image. And you can see the clarity is already there. I'm just backing out. And now what I'm going to do is click on enhancement so we can get the lighting correct. And now you can easily see this red lead is not even bottomed out inside the GX16 terminal. And once again, no flux has been used. This is an accident waiting to happen. If he bumps the lead, if for some reason something comes loose, I'm telling you guys, please proceed with caution. A lot of these content creators do not take how serious what they're doing actually is. The power of artificial intelligence is everywhere. We all know that. I'm using it right now with this software, and this is just a software-based version of a non-physical sense of robotics, which is what we're doing now when we're all in this genre. Physical robotics is just AI in the physical sense. So thinking about how these machines can produce amazing components, when we see things built like this, I cannot emphasize for the do-it-yourselfer who's on YouTube and researching, take your time and review this kind of detail, because this is the detail that will bite you. All right, guys, now we see the content creator once again starting to resolder a connector on his pendant. And you can see that cord that is all coiled up. It looks like a telephone cord. We can tell that is not a double shielded cable, and he should be also able to identify that, and he should be replacing its cable because, of course, it is going to be transpiring signals to the machine, and those signals are once again susceptible to EMI. We then see him continuing to do his typical soldering practice. And of course, he is not using, once again, double shielded cable for this either. He went through and he is just in the midst of doing the tack connections to the GX16.
So I'm going through and wiring up the first stepper motor here. And one thing I like to do is kind of stagger my connectors here so that when I put them in the flex loom, this conduit stuff, there's just not a big fat stack of these butt connectors in a barrel. A lot of times that won't fit in the flex loom and then just makes this big pregnant spot in the wire.
This is a first for this channel in that I've never seen a content creator install crimp butt connectors on his stepper motor leads that are attached to his motor cable that he plans on running through a plastic wire loom. Now guys, this is a horrible idea. This goes beyond worst practice in the sense that, number one, these connectors are not designed for anything in motion. They are simple crimp connectors, which of course we've seen from his past attributes. He doesn't test his connections, so he's hoping these are connected correctly. If you install them on a cable that's active, and as are all cables dealing with motor axis on your robot, you have the potential for failure more so than any other cable because your cables are typically in motion when them axes move. I've said this in previous videos. Understanding the details of what you're working with is essentially critical when you're trying to produce a stable production robot. This goes beyond danger because, again, we do have the potential for arcing. Again, these are his motors, so there's power being run through these cables. This has to be looked at as, once again, of something you will never implement in your own system, especially if you want a stable production robot. And of course, safety comes to mind first, and I cannot emphasize again how bad of an idea this is.
This way. And so here it goes. Power's gonna go on, and if everything goes right, there should be no smoke anywhere. Come on. I do not smell smoke. I heard noise. It freaked me out, but that was the fans kicking on.
When a content creator is overwhelmed with fear, so much so that when he powers his system on and hears the fan spool up, he immediately turns it off. It should define to his audience that he's in way over his head and safety really becomes an issue. I'm telling you guys this once again because if it wasn't on video, many of you would not believe when I tell these stories.
Everything appears to be powered up and working correctly. I'm gonna go ahead and set up the laptop and let's get this thing controlled with the computer.
I've said this in previous videos, guys. Powering on the system just dictates that every device in the system is on, meaning it is accepting power and that everything is functioning according to accepting power. That is the difference with CNC robotics. You do not have a fully functional controller until everything is working and automated. Don't confuse a power test that these content creators like to show and expect that because the unit powers on, your robot is now able to produce products or able to produce anything. The bottom line is you are not able to produce anything until those motors are automating that robot under full, distinct control explicitly. That does not mean that it works for a half hour and then is unstable. That does not mean it works for 5 minutes and then is unstable. I cannot emphasize this enough. These content creators do not understand the terms that they're talking about. They dictate that powering the system on means that now the robot is done. That is the majority of them, and that's what they want you to think. The fact is, and anyone involved in this genre for any length of time will tell you, that robot is not able to be considered functional, actually functional, until it's able to repetitively produce the components it was designed to do. If it can't do that, it's a paperweight, and avoid all of these entertainment videos.
It's come down to time to do the motion test. Got everything loaded up on the laptop. I would have shown you how to set up the parameters and all that, but the control board seemed to be it's it's just not working out.
This is getting interesting. The breakout board the content creator selected, the USB unit, is not working for some reason. Let's see where this goes.
I'll show you. So I grabbed the pennant here. Well, first let's turn it on. So we've got power to the thing. Little green lights lit up, and if I take this pennant, turn it on, turn it to high, everything's working.
I'm sure you guys caught that, and I want to emphasize exactly what we just heard. He's saying everything is working. I've heard this as a vendor for years. I'll get people telling me, well, it's working. What does working mean? Working means that I have motion. Okay, so you have motion. Doesn't mean the robot is working. Did the robot cut anything? Did we see this content creator's robot function as the robot it was intended to be designed for the application it's designed to accomplish? We did not. What we actually saw was that by pressing a button on his pendant, his axis became automated under the pendant's control. That's it. The system did not run a computer file. The system did not function in a controlled manner in which it was designed. You have to take each step as what you're seeing and actually determine how to identify what you're seeing to other people. When people say that their robot is functioning, sometimes what they're saying is that the robot is actually able to be controlled in a manner only under manual pretense. It doesn't mean that that robot is able to produce components by digesting a file inside its automation control software and then disseminating it to the motion of the axis to produce components. That's totally different. And once again, this is where misinformation starts, what we just heard there.
Works great. But
whenever anyone is describing anything and they use the word excellent followed by the word but, you can rest assured there's always typically an issue. With CNC robotics, that issue is usually followed by a major one. And as we see this video go on, I believe he's going to identify it. Let's see where this goes.
if I try to run a program, just hit cycle start here. Everything's moving on the table like it should. Oh, but I need, hold on. Stop. Reset. Let me zero everything out here so it doesn't go trying to travel too far. Oh, it already froze. Alright, so, not responding. I hit stop, it stops responding. And if I unplug the USB controller, boom, it's fine. Plug the USB controller back in, hit reset.
It's a fact now this content creator has defined nothing is excellent with the system. He's actually shown you exactly the problems I've discussed previously in this video and many others in my CNC fail video series about utilizing USB controllers for your system. Universal serial bus is unstable at best due to voltage spike issues, EMI, and grounding. He also defined it even further by unplugging the plug, which of course is not best practice when the computer is running and it's plugged in, but he did it anyways, and he unplugged the plug and then plugged it back in, and miraculously you noticed in the Mach 3 demo screen, which I'm not even sure he realizes he's using a demo version of the software. Many of you do because you've paid attention to the left corner of the screen. But if you look carefully, you can see that where it said not responding on his laptop, it's gone. So that defines that once he plugged in the unit again, like USB typically does, it sees it as a reset, in that everything with the voltages and EMI has been dissipated because it's been unplugged, and then he plugs it back in, and miraculously now he has connection. And what so many end users like himself tend to do is think, oh, it's just random. It shouldn't matter. And honestly, it matters all too much, because I want you to keep in mind what happens when you have a robot that becomes unpredictable and you're cutting expensive substrates. That's when things become serious, and that's when guys should be looking at these videos and wishing that these content creators would keep their own projects to themselves if they don't understand the genre they're working with. Well, guys, that's a wrap for volume number 25. I hope that the video has been enlightening, and I hope you all continue to grow with your learning and understanding of what to look for. I will keep these videos coming as long as they continue to help you. Once again, take your time, do your due diligence, and be careful of entertainment videos posing as educational.